Okay, so let's look at Newton's first law. We know that the law states that the objects that are at rest continue to remain at rest, or the objects that are in uniform motion continue to do so unless they are acted upon by a net external force. A net external force. What do we mean by net external force? Let's take the case of this block shown here. Let's say the mass of the block is m, and then it will exert force mg on the ground, or it gets pulled by gravity towards, and so its weight is mg. An equivalent normal force is exerted by the earth back on the object. This is what is measured in the weighing scale as the weight of the object. So since the object is at rest, there is no net external force on the object, which means mg will be equal to the normal force. If I pull this object up now with my hand, then it will start moving up. That is the net external force. Otherwise, if the object is at rest, whatever external forces that we know of all cancel out each other, and hence there is no net external force, right? So this is case number one. The object can also be in motion and still have all the net external forces cancelled out, or it can have a F net external equal to 0. How is that possible? Let's take this case of a car or a trolley that is moving in this direction. Now what happens is, first let's analyze how did it start moving in the first case. Initially the car would have been at rest, and then a force would have acted on it. Let's say, like in the case 1, if the block had to move, another external force had to pull it up to make it move. So in this case, some force would have acted on the object, the car, to make it move. Let's say there is an engine here inside the car which is connected to the wheels, and then it starts rotating. The rotor is connected to the wheel, and because of that, the car starts moving forward, or rather accelerating. Initially it's at rest and it increases in velocity, and let's say it attains a velocity v in time t. So it was at rest, it is the acceleration that added to its velocity and made it move. But what we are concerned about here is there was a net external force. There was an external force acting on the object, which is why it started moving in the first place and then accelerated, attained a velocity v. So we can clearly see that only when it was disturbed from its state of rest by the external force, it started moving. Then it started accelerating and it attained a uniform velocity. So all the while when it was accelerating, there is a net external force, and then it attained uniform velocity. Once it attained uniform velocity, what is it that what are the forces that are getting balanced out? Let's say it's moving with uniform velocity v in this direction. Still it is moving, right? So our mind, the way we are trained to think, we think that there is some force acting on it. How can we say that there is no force? Always remember, we are talking about net external forces. That means forces are always acting on the objects, but the external forces get cancelled out. That is the key point here. The forces typically are, when the car is moving in this direction, there is a wind probably blowing this way. There is a force exerted by the air, and then there is a frictional force acting on the car. We will see about that. So these forces, the frictional force, let's say friction, and the force from the resistance from the wind, are balanced out by the force of the car which is moving forward. In the sense, the wheels rotate just enough to overcome the friction and the resistance from the wind. They exactly cancel out each other, and hence the net external force is zero. See, internal forces should not be counted at all in this case. The engine inside the car, there could be some forces. We are not concerned about it at all in the first law. The first law only states external forces should be cancelling out. So in this case, the force which makes the car move forward due to friction is balanced out by the frictional force and the air resistance. How does it, I was telling that friction makes the car move forward. Friction also is an opposing force. Let's see how this works out here. Let's take the case of the car wheel, and let's say this is a rough road on which the car is moving. Initially, what will happen is this portion of the tire will grip the road because of the treads on the tire. They will grip the road. Imagine the car is moving on ice, it cannot move, it will be slipping in the same place. The car doesn't move forward. Same happens when the car gets stuck in mud or slush. You see, some vehicles are struggling to get out of the slush because there is no friction. So, in the first place, this point here grips the tread of the tire, grips with the ridges on the road at a microscopic level. If you see, you can see a lot of ridges. It grips with the road, and this pushes the road point at the road backward, and then it gets pushed back by the road forward. That is what causes the car to move forward in the first place, right? And as it moves forward, the next portion of the tire grips the road, and the same event keeps repeating. But this is because of friction, because the rough surface is here, so definitely there is a friction here. But then what does friction do? If, let's say, the engine is not on in the car is in neutral, every time the rubber tire pushes against the rough surface of the road, the velocity of the wheel will also get slowed down because it's getting stopped. Every time it pushes, it slows down a bit, slows down a bit. That is what the engine is doing here. Since it's connected to the wheel, it generates just enough force to overcome that slowdown, prevent the slowing down from happening. So that balances out. In case it's not balancing out, let's say the car is in neutral, what will happen is, because of friction, the car moves forward. That is one thing. Because the tire grips the surface of the road, pushes it back, the road pushes it forward, car moves forward. But then each time the tire pushes the road backward, its velocity also slows down, and eventually it comes to a stop. So if you don't want the vehicle to stop and remain in uniform motion, then there has to be just enough force on the wheels exerted by the movement of the car forward, let's say this way, force of the car, just enough to balance out the friction if we ignore the air resistance. So this is what Newton's first law states. The objects continue to remain in uniform motion or in the state of rest unless there is an external force acting on it. Thanks.